Hey everyone, welcome to another homework. And basically we want to do what we saw in the last video. We want to change a volume values, and what we want to create is this, mysterious, eerie ground fog effect. So what we have here basically is a landscape, and when you look closely, the volume is moving over the surface. So something is definitely moving, that's important. And also, and I made it a bit clearer here, the volume is only on the surface of our landscape here. So it is moving like this, but only on the surface do we have a value. And the end result again could look like something like this, with a couple of trees and a little bit of lighting. I will upload a similar scene, not with the same trees, because I didn't create it and want to make sure that I'm not running into copyright issues or something like that. So you will get a scene with much simpler trees, the trees from the very beginning, from the fundamentals course. But this is what we want to create. And as usual, since this is a homework, the idea is not so much to recreate the exact same look that I have here, but just to experiment around and figure things out yourself. You might come up with a better solution or a completely different result. This is all fine. It's all about practicing. So try this yourself first and then come back to this to look at my specific solution. Okay, so this is what we start with, and all it is really is a very simple mountain over some geometry and then an extrude volume with a little bit of color, and I scattered some trees on the surface, nothing special, and together it looks like this. It looks a bit nicer because I created some light, some environment light with our classic default HDR, tinted a little bit more blue, and then a moonlight, and I created a grid light for this, which is actually not how I would usually do it, but it gives a nicer result in the viewport. So this is my setup, but what I really actually care about is just the landscape really. I ignore the trees for now and the lighting as well. So what we want to do is, of course, create a volume first. Now I take a normal volume because I think it's faster than doing it with VDBs. And I actually would recommend doing this here manually and positioning your volume in the area you need, because otherwise it can be a bit tricky to get the right area with a bound, because if you just take a normal volume and put the geometry itself as an input, so that creates a volume in this area, and let's quickly call this density, of course, this volume, and maybe an initial value of 1, then you can see, and also the resolution is too low, there you go, then you might end up seeing that since we are exactly on the edge here, this can look a little bit ugly, and also on the top it's a bit too little. So what I would need to do here is I want to shrink the edges but increase the top. You can actually do this with a bound. So if you use a bound, you can actually explicitly push in the padding on the edges if you want it, a bit, something like this, and then increase the padding at the top. There you go. So this is totally possible and you can do this. But in my case, I would just, do it with my volume from scratch so that I can really define the area I want. So that's a bit fiddly, but you figure out multiple ways of doing this, I'm sure. So let's now fill this volume. We already called the density to be clean. And of course, what we need is a volume wrangle. And what we want to change or fill is the density volume. So I would right away start with a noise. So let's fill it with a noise based on the current position, of course. And let's right away add some size to this. There you go. And there's actually now a density in this, and you can see this already. But of course, what we need is a bit more contrast. So we use a good old fit with an input min and input max. And we map those to 0 and 1. So now we can change the contrast. Cool, first step. Unfortunately, the noise is not very nice in VEX. A better solution would probably be to do this with WOPs, but this might be another nice homework for you. Try to do the same thing with WOPs, shouldn't be too hard. And now what we need is the distance to the surface. And just like we saw in the last video, that's not too tricky for us at this point. We call this now close P maybe, not P2 anymore, and min pos of course, because we want from the second input, where our landscape is in, there it is, we want the closest position relative to our position of the current voxel. And now we can calculate from that the distance, which of course is the distance between the current position and this closest position on the surface that we found. And we already know that we will change this so that the closer or the smaller the distance, the higher the multiplier will be. So let's do this right away, again with a fit function. So this will be changed from, let's say, if it's a meter away, then the result should be 0. It's 0 meters away, the result should be 1. So something like this, just for us to understand. And then we multiply this with the current density that we already have filled with noise. So we're not overriding it, but we multiply it with our distance, refitted distance. So this already looks pretty good. Let's merge this together to see how it looks. There you go, that's pretty good already. So let's adjust a couple of things. We can maybe make the noise a bit nicer, something like this. And of course, currently we don't control the distance in any way. We just set 1 meter. So let's change this and call this max distance. And we could also change this multiplier, but in this case, I want to add it at the end and give it a kind of a global multiplier and just call this density or something. So this way we can now change the max distance and how strong the whole volume should be, so to say, how strong the density should be. And we can change the distance as well. So this is pretty cool. Cool, so we're almost there. We can change the size of our noise here. We can change the contrast, something like that. We can change the max distance, so how far our fog should be. And we can change the overall density. So that's pretty good, but it's not moving it. So where do we move the whole thing? At the very top, we want to move the noise actually. That's the easiest because that's basically what we see from the whole effect. And I would put this right away onto a vector offset so that we can actually change X, Y, and Z separately. So this way I can now, and you can't see it again because my head is in the way, but this here is the X axis. And I can just put in, for example, $T for this. And now the whole thing should move in X. So this was pretty easy. If you want to add a little bit more complexity to it, you can add more on Y and Z. So for example, it can look a bit more interesting if it also moves down while doing it. It doesn't really look, or it's not supposed to look like it's going down, but it looks more like it's meandering around because it's basically changing its look. We can slow this down if we want by dividing it by 2, and then it, I think, looks relatively natural. So this is pretty cool. It really feels like it's, you know, wandering over the hills. One last thing I would actually do, besides the fact that I would try nicer noise in WOPs, is let's actually also control the distance, not just by the fit function, but actually maybe with a ramp. And that's pretty simple to do. We just add an additional dist line where we just control the distance by a ramp. We call this maybe dist ramp, because we're not very creative. And then we take the dist in as an input directly, because the distance currently goes from 0 to 1. So the range is correct to what the ramp is expecting. And this is why I did it this way. And now we can actually control it even more by stopping the simulation, the running, and then go down here and create a ramp. There it is. And the logic now is when it's 1, it's at the it's close to the surface, and if it's 0, it's away from the surface. So this curve now is already correct. If you want, you can turn it around if you find this more natural, because then you have the hill here on this side. But I kept it as 1 to 0, not 0 to 1. It's up to you. And now the cool thing is I can actually change, for example, the behavior to make the whole thing softer, or even, you know, change it completely to an S-curve, for example. I'm not sure if we see the distance much here, but it is an interesting thing because now you can control the behavior even more. There is something, yeah, okay, there you go, now you can see it. I mean, it seems like below a certain number you don't see the difference anymore, but still, it gives you even more control over the look. Yeah, maybe something like this could be helpful. So it just gives you a bit more control, and maybe if we lower the density, then we have basically a thicker area. Also keep in mind you can still change the max distance, so the area that this curve is applied to, and then you should have a lot of control over the look of your fog. Okay, I think I stop here. The only thing I want to add now, of course, is our trees. So over there they are. Whoop. And now, of course, I will change a couple of things once the trees are in. The only thing I will change now, though, is density. That should be fine enough. And then let's have a look at the end result and appreciate our way too fast misty ground fog in the moonlight when I turn the moonlight on, actually. So yeah, here's the code again. So I hope this is helpful. Thanks very much and see you later. Cheers.